1-8 reading quiz. True or false, the vectors v1 to vp are linearly independent if you take a linear combination of them, set it equal to 0, if that has only the trivial solution. True. That is the definition of linear independence. Okay. That if you put some unknown weights on those vectors, set it equal to 0 and solve, that if x1 to xp all come out to 0 as your only solution, then they are linearly independent. There are several shortcuts of ways that you can see linear independence and dependence without having to set that all up. One of them is if you have only two vectors, you can see it quickly if one vector is a multiple of the other. Is that the case here? No. So these are not linearly independent. We would say that, wait, yes, they are. They are linearly independent. One's not a multiple of the other, so they are linearly independent. So those are both questions from 1.7, and then I got a good one from 1.8. If T is a transformation, which is just a fancy word for function, right? Goes from Rn to Rm, then Rn is the domain, and Rm is called the codomain. Really good. Which is a little bit different from range, right? So we'll talk about the difference between codomain and range in the lesson. Okay, so in this lesson, we're going to look at the concepts of linear independence and linear dependence of sets of vectors. Typically, I don't present definitions and theorems from the reading because you already read it all coming into class in theory, right? But when there's several things that we're going to be referring to in the lesson, sometimes I'll write them out for you. So I did that here today. The definition of linear independence is a set of vectors are linearly independent if, when you take a linear combination of them and set it equal to 0 with some unknown weights and solve, you only get the trivial solution. And then we have three ways that we can determine linear independence, dependence quickly without having to set up that whole equation. So one is that a set of vectors will always be linearly dependent if any vector is a linear combination of the others. So when there's two, that's very easy to determine, like if one is a multiple of the other. Sometimes when there's three, you can determine it quickly, like if you add two together and you get the third, it's really quick to see that. A set of vectors is linearly dependent if there are more vectors than entries in each vector. So that will always turn out to have more than just the trivial solution. So those are dependent. And then third one, any set of vectors that contains the 0 vector is linearly dependent because you could put 0 weights on all the other vectors, add them together, and you get the 0. So the 0 vector is always going to be a linear combination of the others. So that's sort of a special case of that first theorem. All right, so I've got some sets here. 4 of the 5 can be determined to be linearly dependent just by looking at them. So let's look at set R here. What do you think? Dependent or independent? I'll give you a hint. Look at the first and the third vector. Dependent, because 306 is a multiple of 102. Right? So for R is dependent because 306 is a linear combination of the other two vectors. Right? So 306 can be written as 3 times the first vector plus 0 times the other vector. So if one vector is a linear combination of any of the others, it's dependent. Now, if that didn't occur to you right away, what you would do, right, to check if you didn't see that, is you would just set up a matrix where you augment this with zeros, 1, 0, 2, 4, 6, 0, 3, 0, 6, augment it with zeros, and see, do you have only the trivial solution, right? So this should come out to, this has free variables. I'm not going to actually do it right now, but it has free variables. It does not row reduce to x1 equals 0, x2 equals 0, x3 equals 0. That's the only way you would declare linear independence. Okay, what about S? Dependent or independent? Dependent because there are more vectors than entries in each vector. So in that case, even if these first two aren't, one isn't a multiple of the other, then the third one you'd be able to build from the first two as a linear combination. So S is dependent. More vectors than entries. Okay. T, there are 3 vectors and 4 entries, so that one you can't automatically say dependent. Is it obvious that one is a multiple of the other or linear combination of the others? No, T doesn't seem obvious to me, so let's just jump to U and see if we see something quickly. It's got the 0 vector in it, right? So U is dependent because it has 0 in it. And then V, you can't tell? I can tell. Anybody see it? Owen? Sure, you can subtract the second from the third to get the first, or you can add the first 2 and get the third. Yeah. 2 and 1 is 3, 2 and 6 is 8, 2 and 9 is 11. So one of these is a linear combination of the others, so it's dependent. So all right, so T is the one that you can't determine by inspection. It's not obvious. All right, use a method other than inspection to determine whether the remaining set is dependent or independent. So the way you do that, whether it's not obvious from inspection or you just don't see it, right? Like you just don't, like in this V, you might just not see that linear dependence relationship. That's okay. You can always go and set up the equation and solve it. It's just faster if you see a relationship. But for T, we can't tell, so we just are going to augment, turn that into a matrix, augment it with zeros, and see if we get the trivial solution. So basically, I've got 2, 0, 4, 4, 0, 1, 0, 1, 0, 0, 1, 1, augment with zeros. You can use technology from here on out. You can use technology whenever you need to row reduce to RREF. I'm not going to test you on carrying out the algorithm ever again. You just had your only quiz on that. So this row reduces, I did it on my calculator earlier, 1, 0, 0, 0, 1, 0, 0, 0, 0, 1, 0, 0, 0, 0, 0. So if you were to translate this to equations, this says x1 is 0, x2 is 0, x3 is 0. That is the trivial solution when everything equals 0. So this is independent. Linearly independent. If you get anything other than all zeros as your solutions, you would declare it linearly dependent. All right, so that's it for the lecture portion. Work through some of these activities, and then we'll come back together to do the beginning of 1.8 after that.